Now let us solve problems on Laplace transform. Okay. Let us find the Laplace transform for t e to the power of minus t sine t. Okay. First, let us find what is sine t. Okay, which is 1 by s square plus 1. Okay, by shifting property. So let us find e to the power of minus t sine t. So which is equal to 1 by um, s plus 1 whole square plus 1. Okay, this is f of s. Okay, now let us multiply with t, multiplication by t. We have Laplace transform of t e to the power of minus t sine t, which is equal to minus uh, d by ds of f of s. So which is this is minus d by ds of 1 by s plus 1 whole square plus 1. Okay, or you can write as minus d by ds of 1 by this is s square plus 2s and 1 plus 1, that is 2. Now differentiation with respect to s, we get as 2s plus 2 divided by s square plus 2s plus 2 whole square. Yeah. Now let us find another problem on Laplace transform. Laplace transform of 1 minus cos t by t square. Okay. So we will first find Laplace transform of 1 minus cos t, yeah, which is 1 by s minus s by s square plus 1, which is f of s. Okay, so now Laplace transform of 1 minus cos t by t square. So integrate this twice with respect to s. Okay, so this is f of s ds and ds. Okay, let us substitute. Now this is integral s to infinity. We'll integrate the inner integral 1 by s minus s by s square plus 1 ds and ds. Okay. So this will be uh, uh, log of s minus 1 by 2 log of s square plus 1. Okay. Now we have the limits s to infinity. So we are done with the first integral. Now integral s to infinity. Now this will be log s by, now this will half of log s square plus 1, which will be square root of s square plus 1. Okay, keep under the brackets. Now still we have the limits, which is s to infinity ds. Okay, Then applying the limits, we get s to infinity. This will be log square root of s square plus 1 by s into ds. Then again integrating it. So this will be log 1 by square root of 1 plus 1 by s square. Okay, limits s to infinity. So let us substitute it, log 1 minus log 1 by square root of 1 plus 1 by s square, or this will be log s by square root of s square plus 1, or this will be log square root of s square plus 1 by s. Okay. Now let us find the inverse Laplace transform using convolution theorem. Okay, so L inverse of s by s square plus 1 is cos t. Okay, and L inverse of 1 by s square plus 1 is sin t. So therefore, by convolution theorem, we have L inverse of s by s square plus 1 whole square, which is integral 0 to t cos u into sin t minus u du. Okay, so this is 1 by 2 integral 0 to t 2 cos u sin t minus u into du, or 1 by 2 integral 0 to t. Now this will be sin u plus t minus u minus sin u minus t plus u, okay, into du. And so this is 1 by 2 integral 0 to t sin t minus sin 2u minus t into du. Okay, so let us use 2 cos a sin b, which is sin, since we have used that, sin a plus b and minus sin a minus b. So which is, this is half of u sin t minus half plus half cos 2u minus t. Yeah, u is equal to 0 to t. Therefore, this would be half u, substitute it, that is t sin t plus half cos t minus 0 plus half cos t, okay, which is equal to half t sin t, or t sin t divided by 2. Now let us use Laplace transform here to solve the differential equation, okay, which is d square x by dt square minus 3 dx by dt plus 4x is equal to t, given that x naught, x0, which is 1, and x dash of 0, which is minus 1. Okay, so let us solve that. So this can be written as x double dash minus 3x dash plus 4x is equal to t, right? Now Laplace transform on both sides. Okay, so this is a Laplace transform of t. Now this will be s square okay, x square and now this will be x of t, right, minus s of x0 minus x dash of 0 minus 3 s into x of t minus x of 0 plus 4 x of t, right, which is equal to 1 by s square. And now this will be x of t of s square minus 3s plus 4, okay, minus s plus 1 plus 3 is equal to 1 by s square by substituting x naught and x dash value here. So after simplifying, x of t will be this is 1 plus s cube minus 4s square divided by s square and s square minus 3s plus 4. Now we'll use partial fractions here. Yeah. Now 1 plus s cube minus 4s square divided by s square into s square minus 3s plus 4, which is equal to a by s, b by s square, and this is cs plus d divided by s square minus 3s plus 4. Okay, so we get the value of a, b, c, and d. Okay, so after solving it, we get x of t as 3 by 16 into 1 by s plus 1 by 4 into 1 by s square plus 13 by 16 into s minus 29 by 16 divided by s square minus 3s plus 4. Okay. Now the inverse of this x of t will be L inverse of this whole thing. Okay. Yeah. So let us simplify this further. Okay. And then we get, finally we'll get as x of t, which is 3/16 plus t by 14 plus 13/16 e to the power of 3t by 2 cos root 7/2 into t minus 19/32 to 2 by root 7 e to the power of 3t by 2 sine of root 7/2 into t. Yeah. So this is the solution of the differential equation. Okay. Now let us solve this problem. Okay. So this is integral 0 to infinity t to the power of minus 3/2 1 plus e to the power of minus t dt. Now integration by parts. So this will be brackets minus 2 multiplied 1 minus e to the power of minus t, okay, and t to the power of minus 1/2. Okay. Zero to infinity plus integral 0 to infinity e to the power minus t into 2 t to the power of minus half dt. Now simplifying this, by applying L'Hopital's rule, so this will be 1 minus e to the power minus t multiplied t to the power of minus half 0 to infinity, which is equal to 1 minus e to the power of minus t divided by t to the power of minus half 0 to infinity, which is equal to 0. So this is by applying L'Hopital's rule. Okay. Now further, now to integral 0 to infinity e to the power of minus t to the power of minus half dt is equal to 2 gamma 1/2, okay, which is equal to 2 root pi. Okay, so this is the solution. Okay. Yeah, so we'll look at another problem. Now let us look at integral 0 to pi by 2 sine p x cos qx dx. Okay, so this can be written as 1 by 2 integral 0 to pi by 2 sine p x power minus 1 cos q minus 1 x to 2 sin x cos x dx. Okay. Now this is equal to 1 by 2 integral 0 to pi by 2. This is sine square x p minus 1 by 2 1 minus sine square x q minus 1 by 2 2 sin x cos x dx. So t is equal to sine square x dt is 2 sin x cos x dx. Okay, and t varies from 0 to 1. Okay, so let us substitute it. So this is integral 0 to 1. Okay, for t is equal to 0. This is 1 by 2 t power p minus 1 by 2 1 minus t q minus 1 by 2. This is dt. So which is equal to 1 by 2 beta p plus 1 by 2 q plus 1 by 2. Okay, now this is equal to um, gamma p plus 1 by 2 gamma q plus 1 by 2 divided by 2 gamma p plus q plus 2 by 2. Yeah, using beta m comma n, which is equal to gamma m gamma n by gamma m plus n. Okay, now let us prove that gamma 1 by 2 is equal to root pi, right? So we know that integral 0 to pi by 2 sine px cos qx dx is equal to gamma p plus 1 by 2 and gamma q plus 1 by 2 divided by 2 gamma p plus q plus 2 divided by 2. Yeah, let us use this. So here if you put P and Q as 0, so this will be integral 0 to pi by 2 dx, which is equal to uh, gamma half and gamma half by 2 gamma 1. Okay, so gamma 1 is 1, right? So this will be whole square, gamma 1 by 2 gamma whole square. Okay, 2. So on the left hand side you get pi by 2. Yeah, this is now this is gamma half whole square by 2, right? So these two gets cancelled. So gamma half is equal to root pi. So let us prove this. Okay, so we know that integral 0 to pi by 2 sine px cos qx dx is equal to gamma p plus 1 by 2 gamma q plus 1 by 2 divided by 2 gamma p plus q plus 2 divided by 2. So here p is n and q is 0. Yeah. So on substituting it, so 0 to pi by 2 sine power n x dx, okay, which is equal to gamma n plus 1 by 2 gamma 1 by 2 divided by 2 gamma n plus 2 by 2. Okay, so here so gamma 1 by 2 is root pi. So by substituting it, we get on the right hand side, which is n plus 1 by 2 uh, by gamma n plus 2 by 2 root pi by 2. Yeah, so this is the final answer. Now let us prove this. Here again considering integral 0, we'll prove this. Okay, pi by 2 sine px cos qx dx is equal to gamma p plus 1 by 2 and gamma q plus 1 by 2 divided by 2 gamma p plus q plus 2 is divided by 2. Now by substituting p is equal to 0 and q is equal to n. Okay, so this is 0 to 2 cos nx dx. So this will be gamma plus 1 by 2 divided by gamma n plus 2 by 2. Yeah, and this is root 5 by 2. Okay, so this is the answer. So let us solve this. Now let us put x as for y. Yeah. So dx will be 4 dy. So okay. So for x 0, y 0. Okay. For x as 4, y is 1. Okay. So this will be integral 0 to 1. This is 2 root y multiplied 4 minus 4y. This is 3 by 2 into 4 dy. Okay, so which is 8 multiplied 4 to the power of 3 by 2 integral 0 to 1. Okay, y to the power of half 1 minus y is 3 by 2 dy. Okay, so that would be is 64 beta 3 by 2 comma 5 by 2. Okay. Let us solve this problem. Yeah. So again, substituting x as 2y. So dx is 2 dy. So when you substitute x as 0, so y will be 0. And x as 2, y will be 1. Okay. So this will be integral 0 to 1. Okay. This is 2y whole cube square root of 2 minus 2y to 2 dy is equal to 16 root 2 integral 0 to 1 y cube 1 minus y to the power of half dy. Okay, so which is equal to 16 root 2 beta 4,3 by 2. Okay, please subscribe for more videos.